Welcome to this section of this course. Today I will be solving this integral. This integral was asked at MIT Integration V qualifier exam. Here in denominator we have x cube. We can take x common over here and then we can solve this by partial fraction. This can be equals to integral dx upon, if I take x common, here I will get x square minus 1. Now 1 is same as 1 square. So it is, therefore it is a square minus b square. Still I can reduce this as x into x minus 1 into x plus 1. Why? Because we have this formula, a square minus b square equals to what? A minus b into a plus b. So applying this formula, so x square minus 1 square is same as x minus 1 into x plus 1. Now from here let's apply partial fraction. Let's consider 1 upon x into x minus 1 x plus 1 is equals to, let's use some arbitrary constant a upon x plus b upon x minus 1 plus c upon x plus 1. So let's multiply this on both sides. So therefore 1 equals to a into, and x gets cancelled. Here I will have x minus 1 into x plus 1 plus b, x minus 1 and x minus 1 gets cancelled, be x into x plus 1 plus c x into x minus 1. Now our aim is to find these arbitrary constants a, b and c. Now if I substitute x equals to 1 over here in this equation, so let's say this is equation a. Now if I substitute x equals to a in this equation, this term will get 0 as well as this term will get 0. So I will get the values of a. So therefore if I substitute x equals to 1 in equation a, then on the left hand side is constant, so it doesn't affect anything. Now when x equals to 1, this term gets 0, this term gets 0. Here b into 1 plus 1 is what? 2. Yeah, I am substituting x equals to 1, 1 plus 1 is 2. Is implies b equals to what? 1 upon 2. So we have the value of b. Now if I substitute x equals to minus 1, so this term will get 0 as well as this term will get 0. So if I substitute again x equals to minus 1 in equation a, and then 1 equals to x equals to minus 1, this term will get 0 as well as this term gets 0. Here c into minus 1 as well as minus 1 is implies 1 equals to, here this is minus 2. Minus 2 into minus 1 is 2. So here twice c, therefore c equals to 1 by 2. So we have the value of c also. Now we have the value of a and b, so we need to find the value of a. Now we have the value of b and c, we need to find the value of a. Now if I substitute x equals to 0 in this equation, so this and this term will get 0 because we can see over here x into b, c into x. So this term will get 0 and I will get value of a. So if I substitute x equals to 0 in equation a, we have 1 equals to, so a into, here 0 into minus 1 is minus 1, 0 minus 1 is minus 1, 0 plus 1 is 1, and b into 0 is become 0, c into 0, everything becomes 0. So this implies here a equals to minus 1. So we have the values of a, b and c. This value let's substitute over here and then we need to integrate it. So if I substitute all these a, b, c in this equation, then these become a upon x. What is a? A is what? Minus 1 upon x plus what is b? B is half upon. So let's do one thing. Let's integrate also upon x minus 1. What is c? C is half 1 upon x plus 1. So after substituting the values of a, b and c, I am getting this. So now this is what? This is integral. So now let's take integral on both sides. Now if I take integral with respect to dx, let's see. So this equals to minus log of x plus half. This will be what? Log of x minus 1 plus half log of x plus 1 plus some constant is equals to, so this half I can bring here in this. Why? Because we have log property, log of x raised to m is, I can bring this m over here. So m into log of x. Therefore this is same as log of x plus this half I am bringing here. Therefore log of square root of x minus 1 plus this also log of square root of x plus 1 plus c. Now log of m plus n. Remember, log of m plus log of n is same as log of m into n. So by applying this formula, this plus become into. Therefore minus log of x plus log of square root of x minus 1 into, I can take square root of here x plus 1 plus c. Here x minus 1 into x plus 1 is minus log of x plus log of square root of x square minus 1 plus c, and this is same as, I can bring that side. Therefore this is minus log of x plus c. So this is log m minus, here this is what? Log of m by n is same as log of m minus log of n. So log division is same as log minus. So here I can bring this up, log of square root of x square minus 1 upon x plus c. So this is the required answer.